Good morning, students. Today we will solve some more problems on first unit. Okay, in this process, which is shown in this figure, he has asked to find out the work done for a process which is shown in this figure. From the figure, we can easily tell that this process is constant pressure process. That constant pressure is 400 kilopascal. So using this diagram, in this process we need to find out the work done in the process A to B. Okay, from this figure we can extract the data here. Pressure P, the process is constant pressure, which means that throughout this process the pressure will be constant. That constant pressure here is 400 kilopascal. If you convert this kilopascal into pascal, it becomes 400 into 10 to the power 3 pascal. And initial volume at A is 1 meter cube and final volume at B is 2 meter cube. So during this process A to B, we need to find out work done. In the work done in the process 1 to 2 is equal to P into difference in the volume, which is V2 minus V1. So if you substitute these data from these values, and you will get work done in the process 1 to 2 is 400 kilojoule. So this is what the answer for this problem. And here I have shown another way to find out the same work done in the process A to B. Here I have used the formula which is work done in the process, I mean work done in constant pressure process. Here I have shown another way to find out the work done. We know that work done in any thermodynamic process is equal to area under the curve. Here the curve is A to B. If you calculate the area under this curve A to B, and you will get the work done in the process A to B. Here from the figure we can tell that area of the rectangle ABCD is equal to the work done in the process A to B. So we can easily calculate the area of this rectangular using this basic formula AD into CD. Okay, AD is 400. This is here. From here to here it is 300, and CD from here to here it is 10 to the power 3, and finally 10 to the power 3 into 1. So area under this rectangle, area of this rectangle is equal to work done in the process 1 to 2, which is 400 kilojoule. You can follow both the methods. Now let us go to next problem. Let's read out the question first. When the valve of the evacuated bottle, which is shown in the figure, is opened to atmospheric air rushes into it. If the atmospheric pressure is 101.325 kilopascal and 0.6 meter cube of air enters into the bottle, calculate the work done by air. Here he has given a bottle. Okay, this bottle is completely evacuated. What do you mean by evacuated? Evacuated in the sense it is completely vacuum here, which means that the pressure inside the bottle is less than the atmospheric pressure. So that is why when this bottle valve is opened, the atmospheric air will suddenly enter into the bottle. Okay, so that is what the concept. While entering, or for entering the air from atmospheric into the bottle, what is the work done in this process, he has asked. Okay, let us collect the data from the given question. Atmospheric pressure he has given 101.325 kilopascal, or you can convert this into Newton per meter square. Okay, then change in the volume is 0.6 meter cube. How did you say that change in the volume is 0.6 meter cube? You can clearly observe here initial volume will be 0. Why initial volume will be 0 is here initially there was no air here. That is why initial volume of the air V1 is assumed to be 0. Because it is evacuated, once it is evacuated, we can easily tell that there is no air particles, or there is no inside the bottle. That is why initial volume of the air is 0 meter cube, and final volume V2, which is 0.6 meter cube, because once the valve is opened, 0.6 meter cube of air can enter into the bottle. That is why V2, that is final volume, is 0.6 meter cube of air has entered into the bottle. Now during this process we need to find out the work done. We know the formula, the displacement work done by air, that is displacement work W equal to integration of P into dV. This dV is nothing but change in the volume. So you can rewrite the formula as P into delta V. Delta V is change in the volume. So we know the pressure P, which is atmospheric pressure, and delta V, which is change in the volume, which is 0.6 meter cube. And if you do that, you will get the work done during this process, which is 60.8 into 10 to the power 3 joule. This amount of work has done on the system to enter into the bottle.